Alright, so Mathematics 1120 stroke 1100 quiz 1 preparations. Now the first question we have, let E is the universal set, of course, which is running from negative 3 to 8. And then you have got A from negative 2 to 6, B from 0 to 7, and C, which has got X, which is a member of real number such that negative 3 is less than or equal to X, which is less than or equal to 5. Find the following and display them on the number line. The first one we want to find, so these zeros we are seeing here, it means a complement. So the first one we want to find is B complement minus C complement. Now, firstly, the first thing that we need to make sure that we do is we need to simplify this set. We know B complement minus C complement can also be written as B complement. This minus can be turned into intersection, and then you're going to have C complement. But when you change a minus into a complement, they still carry another complement. So this is B complement intersection C. So this is what we want to find. So using a number line, I'll start with B complement. Now, first make sure that you put the universal set on a number line. It's from negative 3 up to 8. And you are including both negative 3 and 8 in the universal set. So I'll just put dots there. Now remember, we want B complement. So the set B is starting from 0 up to 7. You can see that both 0 and 7 are included in the set B, meaning that in the complement will not include 0, will not also include 7. So I'll put open circles, and then I'll just get to connect this side and this side. So what I've shown here is B complement. And then we want where it intersects with C. So C is starting from negative 3 up to 5. And we are including negative 3. So negative 3 I'm going to shade also. And then up to 5, 5 is going to be somewhere here. I'm also going to shade there. That is our C. So the intersection of these two sets. Tina, what's the intersection? From what you're able to see here. Okay. So since we want also to show on the number line, I'm just going to shade this. So this is B complement intersection. See, that is negative 3, 0. Negative 3 is in both sets, but 0 is not in B complement. So this is going to be open. So this is the solution to the first question. Okay. Then the next one, which is part 2, we want to find A intersection B intersection C complement. We have got this 0 here, that's a complement. Couldn't just write that properly. Okay, so that is it. The first thing first, I'm going to deal with this complement. Okay, now remember, we need always to make sure that the universal set is here, because you can't exceed the universal set. So from negative 3 to 8, they are both included in the universal set. Now I first want C complement. C is starting from negative 3 to 5. Let me say we have got a 5 here. So negative 3. Now C complement. Okay. Since look at this, if you check in the set C, 5 is in C. Okay. Meaning 5 is not going to be in the complement. So I'm just going to put an open circle here. And then the line is going to go this side. Another thing, negative 3 we can see is in what? Is in C, meaning that it won't be in the complement. So I'm supposed to put an open circle on negative 3 because we want C complement, not C. C has got a negative 3. Okay, so this is C complement. Now if you can see, the universal set only ends at negative 3. And you don't want negative 3 to be in C, meaning that this set doesn't, negative 3 here doesn't exist. It's not in C complement because you only have negative 3 in C complement, right? But you can see we've put an open circle here, meaning that negative 3 is not there. So it is as good as the C complement doesn't have negative 3, right? So we want where it intersects with B, and B is running from 0 to 7. So 0 will be somewhere here, and then 7. And we're including both sets. So this is going to be shaded. This is also going to be shaded. So the intersection of B and C complement is from here up to here. Like that. So I can just get to bring this down so that I'll not mix up a lot of things. So 5 to 7. Now 5 is not going to be part of the intersection. 7 is going to be part of the intersection because it's in both sets. So B intersects C complement. So I'm now going to consider where this intersects with A. A is running from -2 up to 6. Okay, and we are not including any. So at -2 I'll put an open circle, 6 I'll put an open circle. So this is the intersection. So meaning that this set that we want is running from 5 up to 6, and both are going to be open. So that is it for this question. That is going to be the answer. Let's consider the last part of question 1a, which is saying A complement union B and then minus C. Now A complement union B minus C can also be written as A complement union B intersect C complement. So here I'm going to first get C complement. I think from the previous question we had already seen what C complement is. The universal set is from -3 up to 8. We are including both this and this. Okay. Now C is starting from -3 up to 5. Since 5 is in C, it's not going to be in the complement. So this is going to be C complement. Now -3 is in C, meaning that it is not going to be in C complement, and that's where the universal set ends. So we can't go this side because we don't have anything that side. It's out of the universal set. So I'll simply remove this part here. Okay, and then we want that is a complement, and then we want where it meets or where it intersects with A complement union B. Now where is A complement? A is starting from what? From -2 up to 6. You can see both are not in A. -2 is not in A, 6 is not in A. Therefore 6 is going to be in A complement, and also -2 is going to be in A complement. So this is A complement. Want union B, and then we get the set B. The set B is from 0 up to 7. So let me put it in green. We are including both 0 and 7. That is going to be the set B. So we want the union of the red line and the white, the green line and the white line. So union means combine. Okay, if you combine everything, you combine this everything together with this. So what you are simply going to have, you are going to have from -3. Okay, from -3 you're going to put a dot up to -2. We'll go and also put a dot here, and then we are going to have from 0, we are going to put also a dot. This is going to go all the way up to 8. Okay, we also put a dot because the union of these two is going to connect these two sets. Alright, so don't worry, Tina, the class is under record. You are going to get it. So now we want where this is intersecting with A complement, and A complement is starting from 5 up to 8. Sorry, not A complement but C complement. So the intersection, we can clearly see this is the region here, because the question is saying and show on the number line, so you also need to show. Therefore A complement union B minus C is going to be from 5 up to 8. 5 is not part of the intersection, but 8 is part of the intersection, so that is going to be the answer. Alright, we go to part B. If A is a subset of B union C, and all sets intersect shade B minus C union C minus A. Now we've been told that A is a subset of B union C, meaning that if you have got this is B, and then you have got this is C, A is going to be a subset of the union of these two sets. So if you combine these two sets, A is going to be a subset. What does that mean? We can either have A like this, it's a subset of the union, like if you combine these two sets, or we can have B here, we can have C here, and then we are going to have A here. It is still a subset of the union. Or we can have something like this, B here, C here. If I put A here, it is still a subset of the union. So this question didn't clearly state that. Okay, it didn't clearly state that, at least if the diagram was given. Now for that sake, I'm going to use these two which I've put here to be able to shade. Okay, so this is A, which is a subset of B union C. Want to shade B minus A union C minus A. So B minus A union C minus A, we can also write this as B intersect A complement, and then union C intersect A complement. I can simplify this. We can see A complement here, also A complement here. So I can write A complement, right, intersect, because the intersect is common. And then we are going to have B, and then we have got this sign here, union C. So this is the simplified form. So I want what is outside A but is in the union of B and C. It is outside A but is in the union of B and C. So this is the set. If it is in this one, then it's going to be this one. So that is it for this question. Question 2. Express the following in simplest form given that E, which is the inverse set, okay, and then we also been given that A intersect B is an empty set, meaning that these sets are disjoint. First one we want to simplify is A minus B. The 0 there means complement. Can also write this as A intersect A. This minus also I can change into intersect B complement. We have got a complement, but because I changed this minus into intersect, we are going to have a second complement here. So those two complements are going to cancel out. We are going to have A intersect B complement. So from here, A intersect B complement is a very small set as compared to A. So if we want to shade A intersect B complement, this is A, this is B. You want where A intersects with the set outside B. Okay, this where A intersects with the region outside B. That's the one. That's A intersect B complement. Now we want where this set intersects with A. So every time a small set intersects with a bigger set, the answer is always a smaller set. So the answer is A intersect B complement for this one. So you can't, when you are simplifying set, you shouldn't see the same letter twice. Yes, Tina?
But you said that these are disjoint sets. Now why are they having
Oh, yeah, you are right. So these are disjoint sets. So in a case if these sets were meeting, this would be the answer like that. But since these two sets are disjoint, if you give that answer, then it's going to be wrong. So these two sets are like this. Okay, A intersect B, they don't intersect. So if I'm talking about A complement, we've been told we also have the inverse set here. If I'm talking about A complement, then B complement is going to refer to this part. Okay, it's going to refer to this part. Now we want where that part intersects with A. So you see that the answer is going to be what? It's going to be A. Okay. B complement is that part I've shaded. Intersection A, it will just be this region. So just this part here itself is A. Now where A is intersecting with A is still A. So the answer is going to be A for this question. Is that okay? Okay. The next one we want to find is A intersect B minus B. We know this A intersect B is an empty set. So this is empty set minus B. And this is the same as empty set intersect B complement. And every time an empty set intersects any other set, the answer is always an empty set. So that is going to be the answer for that one. Is it okay?
Yes, it's okay.
Okay. Okay, we have this one expressed in the form the number 2.0005. So the dash starts from this 0 up to 5. Want to express in the form P over Q, where P and Q are integers. Okay, that is it. So how do you get to work out this one? The first thing, equate this number to, just get to equate it to x. So let x be equal to 2.0005. Take note of where the point is starting. This is going to be equation 1. Then make sure that the decimal is in front of the repeating number. So I'm going to multiply equation 1 by 10 because we only have one number before the decimal. So x times 10, that is going to be 10x, and that is going to be 20.005. And then next thing, make sure that the decimal point is after the repeating number. So multiply 2 by, we have got three numbers there, so by 1000. So 10x times 1000, that is going to be 10,000x, and that is going to be equal to 20,005 point. So the decimal point will come. And now just to maintain the values after the decimal, just put 005 also. So be equation 3. And then the equation with a decimal point in front of the repeat number and the equation with a decimal point after the repeat number, I am going to subtract those. So we have got 10x, which is 20.005. 1000 minus 10, that is going to be 990x. So this and this will cancel. So all we are going to do is 5 minus the 0 there is going to be a 5. And then we are going to remove a 1 from here to put it becomes the 10. Remove a 1, move a 1, it goes there. So 10 minus 2, that is going to be 8. Then we have got 9. So therefore x is going to be 9905 divided by 990. So if there is a number that can go into these numbers without leaving a remainder, we make sure that we get to divide. Otherwise, if we leave it in that form, if it can be divided, you are going to lose 1 mark for that portion which needs simplification. So this one, in the simplest form, 9905 over 990 can be written as 1981 over 198. So expressing the simplest form, so that is it. And then part 2 is saying give an example of the sum of two irrational numbers which is rational. Give an example of the sum of two irrational numbers which is rational. Do you know any? Two irrational numbers which are rational. Okay, if you look at square root of 2 plus, let's say, square root of 2, what are we going to have? This is going to give us 2 square root of 2, and this is still irrational. I don't know which one are we able to pick. Are you thinking of any two irrational numbers which you can add to give you a rational number? Hello? Okay. So let's try another one. Okay. So let's say if we have got 7 plus 3. Okay, let me say just a very simple one. Let's say we are talking about 2 minus square root of 3. We know that this number is irrational, right? Now let's say if we add it with root of 3. So this and this is going to cancel. We are going to remain with 2, and 2 is rational. So that is an example we can give. Okay, the next question. Express the following in express, so supposed not be there, in terms of the simplest surd. So I've got square root of 96 divided by negative 8 square root of 24, then minus the 3 square root of 6. So to be able to work out this one, first thing we need to look at 96. We see how we are able to simplify it much further. How can we express square root of 96 in the simplest form? So square root of 96 is the same as 4 square root of 6. That is because 6 into 96 goes there 16 times. So this is 4 square root of 6. And then in the denominator, 6 can go into 24 4 times. So the square root of 24 is the same as 2 square root of 6. And then we have got minus 3 square root of 6. So this root 6 will cancel with the root 6 there. Okay. And then 4 can go into 8 2 times. So this is going to give us 1 over negative 2 times 2, that to be negative 4. And then minus 3 root 6. So this is the same as negative 1 over 4 minus 3 root 6. So that is it. So let's also get to answer this one. Express 3 minus 2 root 3. So divided by 3 square root of 3 plus 7 square root of 27 minus 4. So the first thing also we need to simplify this root of 27. Now root of 27 is the same as 3 root 3 because 27 is 9 times 3. Square root of 9 is 3. So this is 3 root 3 also. So 3 root 3 plus 3 root 3. We just add the 3's which are outside. That is going to give us 6 root 3 and then minus 4. So now get to rationalize the denominator. Multiply on top by 6 root 3. We'll change it to 4 and then divide by 6 root 3 plus 4. So let's get multiply 6 times 3. That is going to give us 18 root 3. And then 3 times 4. That is going to be a 12. And then negative 2 root 3 times 6 root 3. That is going to be negative 12 and then a 3. And negative 2 root 3 times 4, that will be negative 8 root 3. In the denominator, get the first number which is 6 square root of 3. You square it and then minus. You get the second number which is a 4. You also square that. So 12 times a 3, that is a 36. So 36 plus 12, that is going to give us a 48. And then 18 root 3 minus 8 root 3, that is going to be a 10 square root of 3. The denominator are going to have 6 root 3 squared. 6 squared is 36. Root 3 squared is just the 3 minus 4 squared, which is a 16. So 36 times 3, that is a 108, and then minus 16, that is a 92. So all we do is now split 48 over 92 plus 10 root 3 over 92. Now just 48 divided by 92 itself can be further divided to 12 over 23, and then 10 over 92 can also be more simplified to 5 over 46, and then we have got root 3. So that is going to be it for this one. Okay, consider this one also. Evaluate negative absolute value of negative 3 minus 3 absolute value, okay, minus, let me make sure that I don't put, okay, absolute value of 3 minus, like that. Now this is going to be a little bit trick if you don't know how to pair up these absolute bars. So this first absolute bar will go with this with this absolute bar. This one is going to go with this one, right? Then this one is going to go with this one. This means that negative 3 is in absolute bars, negative 1 is also in absolute bars, and then 3 is in absolute bars. Is it in absolute bars? No. So the first thing that we are going to do, again I'll repeat, such a problem like this one is a bit of trick. So make sure that you follow it well. So take note, we have got a big absolute bar, and then this one. This negative 3 is in a bar, and then this 3 is also in a bar. So make sure that you follow it like that. So we're going to have negative absolute bar, okay? This negative 3 is not in a bar. So we're going to have negative 3, and then the absolute value of negative 3, that is positive 3. Then you have got this minus here, minus, and then the absolute value of positive 3, that is a positive 3, and then you have got now a minus 1. So just failing to do this means that we can't answer this question. So this is negative absolute value. Negative 3 times the 3, that is a negative 9, minus 3 minus 1 absolute. So this is negative 9 minus 3 minus 1, that is going to be negative 13. Absolute value of negative 13 is positive 13, but multiplied by this negative outside, that will be negative 13. So that is the answer for this one. Alright, find the real and imaginary part of 2 minus 7i plus 2i to the power 5 minus 1 minus 3i. So this is the same as 2 minus 7i. Now what is 2i to the power 5? We know that I squared is negative 1. If I square everything here, I squared becomes I to the power 4. Negative 1 squared is positive 1. If I multiply this by I to the power 4 times I is I to the power 5. 1 times I is I. So I to the power 5 is the same as I. So this is the same as 2i. So negative times 1, that will be negative 1. Negative times negative 3i, that will be positive 3i. Add now like terms. So 2 minus 3, that is a 1. Negative 7i plus 3i, that is going to be negative 4i. So that is it for this question. Right, let's consider this one. Let the binary operation star be defined on R by A star B being equal to this was supposed to the square root of A plus B. Evaluate. The first one we have got 16 star 9 and then star 41. So this is the same as the first term. This is going to be A, this is going to be B. So meaning that it's going to be 16 plus 9 square root in square root. This is going to be square root of 16 plus 9. The answer that we are going to get, and then star 41. So 16 plus 9, that gives us 25. We know that the square root of 25 is a 5. And then star 41. This will give us, again, this will be a, this is going to be b. So that means square root of 5 plus 41. That is going to be square root of 46. Now, well, what is the square root of 46? That is simply square root of 46. We can't reduce that. So that is going to be the answer for this one. And then part 2, we want to work out 13 star 3 star 6. So this is going to be 13 star. We first work out what is here. So that is going to be square root 3 plus 6. So this is going to be 13 star. 3 plus 6 is a 9. Square root of 9 is a 3. And then this 13 is a. So this is going to be square root of 13 plus 3. So this is going to be square root of 13 plus 3 is 16. Square root of 16 is a 4. So that is it. Alright. Let A be elements 0, 1, 2, 3, 4 and B negative 3, negative 2, negative 1, 0, 1, 2 and 3. Determine whether or not the set of ordered pairs, these ones which are here, represent a function from A to B. So let me first write A here and then B here. So obviously we can see for the first we have got 0, we have got 2, we have got 1, we have got 4. Definitely these come from set A, because in set B we have negative numbers and we can see a negative number here. That definitely can't come from A. So the first ones are representing A. So we have got 0, we have got 1, we have got 0 here, we have got 1 here, we have got 2, and then we have got 4. I'm just writing them in order. 0, 1, 2 and 4. The other side we have got negative 2, 0, negative 1, 2. So starting the smallest, that's a negative 2. Then we have got negative 1. Then we have got 0 and then we have got a 2. So we now see how these are pairing up. So you can see 0 is pairing up with a negative 2. And then 2 is pairing up with a 0. And then we have got 1 pairing up with a negative 1. 4 pairing up with a 2. So, is this a function? Yes, it is a function. Why? Because every value in the input set A has got some value in the output set B. Every value in the input set A has got some value in the output set B. And only one value in the input has been mapped to one value in the output. Otherwise, if this set was, let's say it was like this will still be a function, because all the values in A have been paired to some value in B, even if you don't, this one is not paired. Now, if this one, let's say, was like this wouldn't be a function. One reason is that you can't have two y values coming from the same x value. Another reason is that an x value cannot be unpaired. So the one that you've been given is actually a function. Alright, so this is it for this tutorial. Thank you so much for watching. Stay blessed.